data I will present today demonstrate that we can take stem cells and push them down a path that produces T cells in a dish. T cells require several elements to be in place to grow from stem cells, and one of those elements is a 3D architecture made up of specialized stromal cells. These stromal cells produce a supporting environment that makes the stem cells grow into the T cells, and one approach that others have taken is to create this 3D stroma using mouse cells or other supporting cell lines. This is a fine approach, but thinking ahead about making these cells available to patients in the clinic, I think that it's better to have a system without the complication of mouse cells or any other stromal line. So there's a risk of potential contamination in the final product. What we've been able to do is to make stem cells grow their own 3D stromal architecture, thereby helping them to produce T cells without introducing another cell line. Another key point and difference with our process is that we've done this without adding human serum to the culture media. Again, like the mouse stromal lines, human serum could be another source of contamination. There's also a lot of variability between batches of serum as it's derived from multiple donors. So we've developed a proprietary set of culture conditions where we add known amounts of defined factors. And this has enabled us to get to the point that we can make T cells from stem cells in a dish without the addition of stroma or serum. The true test of how this platform works will be how these cells behave in patients. But I'm happy to report that we've cleared yet another hurdle towards this goal. When we were able to put one of our SPEAR TCRs into these HIPSC-derived T cells, we could get the cells to become activated when they were exposed to a specific cancer target. There's still a lot of work to do before we can get to test these cells in the clinic. However, I'm really proud of the work from the teams and our progress to date. So stay tuned for more updates. I want to thank my team at Adaptimmune and our collaborators at Universal Cells, now Astellas, who we're partnering with on the gene editing technology for this platform.